Today we're going to do a titration of vinegar. So we have 5% vinegar solution, we have our distilled water, we have a 0.1 molar sodium hydroxide solution, we have our phenolphthalein indicator, an Erlenmeyer flask, and our burette tube filled with sodium hydroxide. So let us begin the titration process. Okay, I will start by gathering 5 milliliters of my vinegar solution. So using a pipetter, I will drop 5 milliliters of vinegar. So right to the 5 millimeter line, and I will add that to my Erlenmeyer flask. To that, we will then gather 20 milliliters of distilled water. So I will gather 5 milliliters, and we will do that 4 times. So there's 1, and we'll gather another 5. And there's 10. And we will gather another 5. And the last set of 5 will give us the 20 milliliters. So now we have our 25 milliliters of solution, 5 milliliters of vinegar, and 20 milliliters of water. And to that we will add 5 drops of phenolphthalein solution. 2, 3, 4, 5. Now notice it clouds up a little bit, but if you swirl that around, it will go clear because phenolphthalein is clear in an acid solution. And now we will begin the titration process by adding some sodium hydroxide to our acid solution. You will notice that we are going to start seeing pink, and as we swirl it, the pink will disappear. So we will add it at a little faster rate. See the pink forming, and we'll swirl it and we'll notice the pink goes away. And our job as we titrate is to bring it to a point where the pink color holds even though you may swirl it. So I'm going to slow down this process now, and we will just go a few drops at a time. We don't want to go too fast because we don't want to go past what is called the end point. The end point is where the pink color stays, and we want to find that one moment when that end point is reached where the pink color remains even though you continue to mix it. What you'll start to notice is that the pink color stays longer and longer. You notice that the pink drops along the side of the beaker where the splashing occurs remain that pink color as the phenolphthalein reacts with the sodium hydroxide, realizing that phenolphthalein is clear in an acid but will be pink in a base. Now we're starting to get to that point, and I'll bring this closer to you. What we have there, see, still clear. So I think we can add a few more drops. We're starting to see the pink color. Let's slow that down again. as we, nope, not quite, we still have clear. And I think we can just get a couple drops going at a time. There we go. Still clear. Not quite. Not quite. There we go. Now we've got the pink remaining, and that is the end point of our titration. And now we're going to read the amount of NaOH that we used in this titration, and that gives us a 44.4 milliliters, reading the bottom of the meniscus of the reading on the burette tube, 44.4 milliliters. So this neutralization reaction includes acetic acid, HC2H3O2, plus sodium hydroxide, NaOH, which ionizes into Na plus ions, sodium ions, plus acetate ions, C2H3O negative, in water. And our equation, or our values, we have 5 milliliters of the acid. We are looking for the molarity of the acid. We have the base is 44.4 milliliters, and we know that molarity to be 0.1 molar. Our equation is NBVAMA equals NaVBMB, but because the mole ratio is 1 to 1, we simply have to do VAMA equals VBMB. So using the algebra and canceling out the milliliters, we get a molarity of 0.89 molarity, or molar, and for 5% vinegar solution, the molarity should be 0.87. So we're pretty accurate here.